Welcome to Klein's Geometry. We're going to look at lesson 3.3-6, lines in the coordinate plane. In 3.5, we looked at slope and how if lines are parallel, they have the same slope, and if they're perpendicular, they have opposite reciprocal slopes, and if neither condition exists, we know the lines simply cross. So today we're going to look at more lines. We're looking at graphing lines and writing their equations in slope-intercept form and in point-slope form. And we're going to look at classifying lines as parallel, which we've already done, intersecting, which we've already done, or coinciding. That's our new word. All it means is what a coincidence. When we put the equations in the same form, we have the same line. So it's possible they're parallel, it's possible they intersect, it's also possible that it's just two versions of the same line, in which case we call them coinciding equations. So, forms to look at, or things to look at, point-slope form and slope-intercept form of an equation of a line. Recall, the slope formula is y equals, or m equals, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Recall, rise over 1, run the change in y over the change in x. Now, if I were to take this equation and multiply both sides by x sub 2 minus x sub 1, I would get, and I'm going to put this on the other side, that is simply the distributive property. When I do this, now if I take off, I guess I'm not very good at that. If I take off the subscript, this is point-slope form of the equation of a line. It comes from the slope formula. You could also see it written like this. If I add the y sub 1, we get this. These are two versions of point-slope form. Now the variable, this is the point that we know is on the line. We might see it here, we might see it here. And this is the slope of the line. And the x and the y are variables. Now if I were to take this equation, y equals m times x minus x sub 1 plus y sub 1. Now if I take this and I use the distributive property, now these are both just numbers. I could add them together, and we're going to call this b. And it's actually the y-intercept of the line. So now I have my slope, I have my y-intercept, and this is slope-intercept form. Point-slope form, the slope formula, slope-intercept form. And they all just come from the idea that we measure slope as rise over run. So point-slope form, here you go. Two versions. Slope-intercept form, here you go. They both come from the slope formula that you learned last lesson. So, equation of a line can be written in many different forms. We just saw that. We saw point-slope form, slope-intercept form. There's also standard form. And the point-slope and slope-intercept forms of a line are equivalent. You just saw that. I just manipulated the slope formula and got both forms. And because the slope of a vertical line is undefined, remember all vertical lines have equation x equals whatever their x-coordinate is. These forms can't be used. We can't use these forms to write the equation of a vertical line. There's no slope involved. We always just write it x equals, and that's our equation. So this should be in your notes. It's in your book. Point-slope form, y minus y sub 1 equals slope times x minus x sub 1. Here's some examples. X sub 1, y sub 1 is a point on the line. There's lots of points on a line, so you can have a lot of equations describing the same line that look different. Slope-intercept form, y equals mx plus b. Well, in this case, m is always the slope and b is the y-intercept. So if it's in this form, we will recognize a line. Okay, so this is the form we shoot for when we're comparing two lines. And vertical line, x equals a, where a is the x-intercept. And a horizontal line, we talked about y equals b. B is the y-intercept. So, because we know horizontal lines have a slope of 0, vertical lines have a slope that's undefined. So, a line with the y-intercept b, remember when you get something, maybe they say, hey, the y-intercept of an equation, a line is this, then what we know is the x-coordinate is 0, and you know a point. And if you know the x-intercept of an equation is this, well, then the y-coordinate must be 0, so you know a point. So you can get points if you're given x-intercept and y-intercept. Just make the other coordinate 0. So now we want to write the equation of a line in the given form, and we're going to write a line with a slope of 6 through this point in point-slope form. So all we do is we write point-slope form. We know this is x sub 1, y sub 1, and this is the slope. We put them in, and we're done. Well, we're almost done. Since this was a negative, minus a negative is the same as positive. So we'll just, we're just going to clean that up, and we'll write y plus 4 equals 6 times x minus 3. So you want to clean that up to get your last thing. So here's point slope form. This is a little cleaner version. Anytime you see minus a negative, make it positive. Now here we want to write the equation of a line through these 2 points in slope-intercept form. Well, you've got to get the slope form first. So use your slope formula, y sub 2 minus y sub 1, x sub 2 minus x sub 1. And you're just thinking x sub 1, y sub 1, x sub 2, y sub 2. And you find the slope. You need to know what m is. And then your y-intercept, well, start with point slope form. Y minus y sub 1 equals slope times x minus x sub 1. Put in what you know. I know the slope is 1. And I can use either point, and I'll get there. I like positives, so I'm going to go with 1, 2. 2 is the y, 1 is the x. Now I just simplify this like you saw me do to get from point slope form to slope-intercept form, and I've got it. So y minus 2 equals 1 times x is x, 1 times 1 is 1. Distributive property. Add 2 to both sides, and I end up with y, this is a 0 then, equals x minus 2 plus 1, 2 minus 1, essentially. And there is slope-intercept form. Another way to do it is look at your slope-intercept form, put in a point x and y, solve that to get b. So either way will work. Now, here we want to write the equation of a line with the x-intercept of 3. So I know that's the point 3, 0. X is 3, y is 0. Y-intercept is negative 5. So I know that's the point 0, negative 5. Because negative 5 is y, so x has to be 0. In this case, there's my points. I find my slope. Just put the 2 points in the equation. And then I plug in, I can do it 2 ways now. I can say y minus equals, my slope is 5/3, x minus. And I was given 2 points. The x-intercept is 3, 0. The y-intercept is 0, negative 5. I can use either one of them in there in point slope form. So I can put in 3 for x and 0 for y, or I can put in negative 5 for y and 0 for x. Both of these are correct answers. Use your favorite point. And point slope form, so you're done at that point. You might want to clean that up and say plus. And this says point slope form, so you can simplify this. You don't have to if you've got a 0. Now to graph. Remember when you graph, here's my equation. It's slope-intercept form, mx plus b. Here's my slope, and this is my y-intercept. Okay? So I'm going to start at my y-intercept, start at B on the y-axis, and then I'm going to plot the slope. And I know if my slope is, it's rise over run. If my slope is positive, go up. If it's negative, go down. And then go to the right, whatever's in the denominator. So I've got a slope of 1 over 2. And I can go up 1 over 2 again. You can see it still be on the line. I could also reverse this. If I was, since all of this pertains to going right, if I went down for a positive slope, I'd go left. And you can see another point here. And there's also another video on just on this. If you had trouble with graphing in algebra, go back to the Patrick video, Just Math Tutoring, and watch the video on just graphing lines. Now if I wanted to graph this line, here's what I know. It's in point slope form. So this is, so I know this is y sub 1. And that's, okay, I need minus to get x sub 1. So I know this positive is minus a negative. So now there's my formula, and there's my x sub 1. It's going to be the opposite sign. This is the opposite of whatever this is. This is reading the opposite of whatever this is. Since it was negative, I know I'm positive. So the point is going to be -4, that's x, and 3, that's y. That's my point. My slope is -1, or -2. Which if I plot, I think of this as 2 over 1, so I'm going to go down 2 to the right 1. Or if I want to go the other way, if I want to go up 2, I've got to go to the left 1 from this point. So here's my point. Down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And you can find all of these points, and that's what I want to see you do when you graph it. Don't just give me 2 points in a crazy line. Down 2 to the right 1, plot them on graph paper, through your book, or through your sheet, and then give me a nice straight line, okay? And then you draw that line, and you put arrows on the end, because that's what we know about lines. They're infinite. Now when we graph lines that say y equals -3, we know there's no slope. Slope is 0. This is a horizontal line. I always had trouble with those when I was younger, so I think, okay, y equals -3. Doesn't matter what x is. Doesn't say anything about x's. 0, 1, 2. So there's some points. And when you plot those points, you'll always see that horizontal line. So there's your line. Put your arrows on. And there is your answer to y equals -3. Now when you've got a system of lines, system of 2 linear equations, 2 variables, it's really just 2 lines. And you want to know, are they parallel, in which case there's no solution to the system? Do they intersect, in which case you'll get one solution? Or do they coincide? Coinciding means if you change the equation, put them in point slope intercept form, they're going to be run on top of each other. That means they're the same line. So parallel lines, same slope, different y-intercept, intersecting, different slopes. Coinciding, when you get them in y equals mx plus b, slope-intercept form, they're the same equation. This needs to be in your notes. Now we look at these. The first thing I'm going to do is I'm going to look. Right here's my slope. Right here's my slope. They're different. I look back at my table and I say they intersect. And that's all you need to say. You look at this. This is not slope-intercept form. So I need y alone. I'm going to divide by 6 and get y equals, and 2 over 6 reduces to 1/3. And 12 divided by 6 is 2. So there's my new equation. Now I see this slope, same slope. If they have the same slope, they're parallel if the y-intercept's different. If these were the same, if they were both 5 or both 2 or both anything the same, they would be coinciding. But same slope, different intercept, we're going to call them parallel lines. Lines are parallel. This takes a little more. We need y alone before we can find out. So the first thing I'm going to do is add 4x to both sides. You know, this is on the slide. So we have to solve both of them and find slope-intercept for them. Add 4x, divide by 2. Here's your equation in slope-intercept form. Do the same thing with the other one. Distribute, add 10. Now we end up with, what a coincidence! Same equation. Coinciding lines. They coincide. They're the same line. Okay? Now how do we use these with systems? Erica is trying to decide between 2 car rental plans for how many miles will the plans cost the same. These are the sorts of things we use this for. I know the initial fee for plan A, you're going to have $100 just to get the keys, and it's going to cost you 35 cents a mile. Anytime you've got that rate per mile, you know, there's your slope. Plan B, it's only $85 to get the keys, but then it's 50 cents a mile. So the first thing you want to do is understand the problem, and the answer is going to be the number of miles that you would travel, that the cost for the 2 plans would be the same. So when you're thinking per mile, you got a slope, because that's a rate. So now we can actually make our mathematical model. We can write equations for the plans and graph them, and the solutions where they intersect. Okay? And we're going to solve the system to find that. We did that in algebra, and you might do that by graphing. You might do that by elimination. You might do that by substitution. See what we got. Plan A, 35 cents a mile, so that's 0.35 times x, or you could put m, I usually do per mile, plus $100 to get the car. Plan B, 50 cents a mile, so 0.50 times x, plus 85. And this x stands for the number of miles, okay? And maybe you just put an m because that makes sense, and a c here for cost. It's kind of weird how they do these things with x's and y's. And we just want to solve this. Now, one way to solve it would be to look and say, okay, if I subtracted this, the y variable would drop out. And anytime you see that, you always want to solve the easiest way. So we're going to do that. And then we just add 0.15x and divide by 0.15, and you get x equals 100. So that's 100 miles. Well, that's how many miles she would travel. What would it cost? You can put 100 into either equation, and you find out it costs $135. So solve the system, and you know the answer to that. Now let's look at that on the graph. If you were to just graph this by hand, you would not see this. That would the lines cross at 100 and 135. So you know this is miles. Always label your axes, miles and cost. So you know you drive 100 miles, it costs $135. You look back, does that make sense? Here's how you do that with a calculator. First thing you're going to do is you're going to put both equations in your y equals menu. Notice I've got y equals 0.35x plus 100, 0.5 or 0.50x plus 85. Then you have to think, what's reasonable? Oh, and I'm just going to go 0 to 150. You could do different things, but I figure 150 miles, she's probably not going to drive more than that. $150, hopefully she's not going to pay more than that. So to me, those seem reasonable. I like my scales big because I don't like to see a bunch of hash marks, so I just went by 50s. Do whatever you want there. Then you press graph, and this is what you get. So this is 50 miles, 100 miles, 150 miles. This is $50, $100, $150. And I want to know what is this value? So what I'm going to do is on my calculator, I'm going to go to calc, which is this is second trace, the second key and then the trace key, and you'll see the word calc above it. And I'm going to calculate where it intersects. So it's going to say to me, first curve. And I'm going to arrow key to the left of this intersection, and I'm going to press enter. And then it says second curve. Now I've got to be on the other side of the intersection. So I'm going to arrow key over to the right side, and I press enter. And then it said, should I guess? Please do. And it says, if she drives 100 miles, it costs $135. So that's a quick and easy way to solve a system of equations. If you've got slope-intercept form, point-slope form, put them in that y=, menu, find a reasonable intersection or window, and just calc intercept. So, in summary, we know that coinciding lines are lines that are the same in point-slope form, or slope-intercept form, lines in point-slope form they can trick you. It might be the same line, but if you've got different points in there with a slope, you don't know until you put it in slope-intercept form. And all three forms come from the slope formula. So hopefully you've taken some good notes to show me, and that's the information in lesson 3.6. See you in class.